Okay, so chapter 1, algebra. So first we already done with long division, synthetic division. Second, we already completed with a remainder theorem, factor theorem. And number 3, we completed partial fraction. Number 4, we completed binomial expansion. Number 5, we're going to look at inequality. Okay, we're going to look at the inequality. So inequality that we have here, okay, of course we have from the past, okay, one linear form, one quadratic form, or whatever, you already have understand it. So, oh, sorry, I left out. I shouldn't start with the inequality first. My mistake. Modulus function. Modulus function. Okay. So before we enter inequality, we should deal with the modulus first. Okay, we are solving questions like modulus. Okay, solving equation. We can have a square both side method. Okay, we can have an analytic method. Okay, you have to understand that square both side methods doesn't work all the time. So technically, square both side methods, okay, yeah, well, I will just ignore it lah. Okay, I will go only to the analytic method. Okay, so question, okay, such as let's say I have questions like modulus of x minus 2, x minus 1, okay, modulus that equals to 1. Okay, let's say I have this question. So if we look at the graph transformation itself, okay, so this is what I have for the x minus 1, x minus 2. When we convert it into a modulus transformation, I will have a graph that look like this. Okay, so I have a x minus 1, x minus 2 with the modulus. Okay, then if I want to solve these questions, okay, I may need to split it into the positive sign and the negative sign. So I have x minus 2, x minus 1 equals to positive 1, x minus 2, x minus 1 equals to minus 1. Okay, so if we solve them, okay, expanded them, so I will have a x squared minus 3x plus 2 plus 1 plus 1 here. Okay, then I have a x squared minus 3x, so this one plus 2, then will be a plus 3 over here. Okay, so from here you actually square both sides. We see that what are the answers that we have. So if I press calculator, polynomial 2, okay, 1 equal minus 3 equal 1 equal. So I have a 2.62 and 0.382. If I solve for the second one, 1 equal minus 3 equal 3 equal. So I have a complex number, so this one no real roots. Okay, so you will see that this will be a question that without the no real roots for the negative sign. So that means we only have two answers over here that actually satisfy the question. Okay, So if let's say students do it by using square both sides, if students do square both sides, so you will realize that if you do by square both sides, you have a x minus 2, x minus 1, then the entire thing square and equals to 1 square. Do you think you'll be able to solve these questions? X minus 2 square, x minus 1 square equals to 1 square. Okay, so it becomes too complex. This will be the example that I'm trying to tell you that a square both side method may not work all the time. Okay, it may not work all the time. Example. Okay, so we can also do a question that actually maybe work like this. Maybe of modulus of x minus 3, okay, plus 4 equals to 5. Equals to 5x. Plus x, okay, maybe. Plus x equals to 4. Okay. So before students actually continue with the questions, okay, students can actually try to arrange them properly. So I'm trying to rearrange them into a nicer form. So maybe I move the x over to this side. I have a 4 minus x. Then only I split them into two brackets. So I will have a x minus 3, okay, equals to positive of 4 minus x. Okay, I have maybe a x minus 3 equals to negative of 4 minus x. So x minus 3 equals to 4 minus x. So I have a 2x equals to 7, x equals to 3.5. So if I do it this way, x minus 3 equals to minus 4 plus x. So x cancel off. You have a 1 equals to 0. So this one no solution. Okay, then we have one answer over here. Okay, so let's see. Let's say for it's just a different way. What if we have two modular sign? So x minus 3 equals to modulus of 4 minus x. What if you have two modular sign over here? Okay, if we have two modular sign, okay, of course we can split it into the combination of plus, 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 minus, minus, plus, and minus, minus. Do you agree? Okay, then you'll realize that since it's a plus, plus, and minus, minus, these two is actually just the same thing. These two is just the same thing. Therefore, you only have two cases. Okay, only two cases. So we will have a form of x minus 3 equals to positive of 4 minus x, and x minus 3 equals to negative of 4 minus x. In the end, we do. Okay, we only have one answer. No solution. Okay, so other than doing solve by algebra, okay, we also can solve by graph. We can also solve by graph. So therefore, the graphing technique is very, very important here. So for example, modulus x minus 3 equals to 4 minus x over here. Let's say I treat this as my y1, this one as my y2. Okay, my y1, x minus 3 graph over here. So I have this is a 3, this is a 3. Okay, this is my y1. Then I have my y2, 4 minus x, I have 4 here. You'll realize that I only intersect at one point. 3 point something, 3.5. Oh, consistent, as you can see. So if I looking at these questions, okay, modulus of x minus 3 equals the modulus of 4 minus x. So this is my y1. This is my y2. Okay, so I draw it up. My x minus 3 modulus is still the same thing, which give me this. 3 and 3. Here, and 4 minus x, because of the modulus, it give me this. 4 and 4. The working is still the same. You still have only one interceptions. So far so good. Okay. Now, what if we have increased the difficulty? So x minus 3 equals to 4 minus x minus 2. Okay. X minus 3 equals to 4 minus x minus 2. Then at this moment, because the minus 2 is outside of the interval, now we have no choice but to have 4 cases. Okay. So we have a positive of x minus 3 equals to positive of 4 minus x minus 2. We have a positive of x minus 3 equals to negative of 4 minus x minus 2. We have a negative of x minus 3 equals to positive of 4 minus x minus 2. We have a negative of x minus 3 equals to negative of 4 minus x minus 2. Okay, so over here you can see that we want to train students to be analytic sensitive. Okay, analytical sensitive, so that students actually can consider all cases all the time. So for the first one, okay, x minus 3, x 4 minus x, I have 2x equals to 2x equals to 4. This one is 2x, so this one 4 minus 2, 2 plus 1, 5, so x equals to 2.5. This one positive x and positive x, this one no answer, no solutions. This one minus x and positive x, so this one minus x and minus x, this one also no solutions. This one minus x plus x, so this one I have a 2x equals to minus 3, minus 4 minus 2 minus 6, bring it over, become a 3. So x equals to 1.5. This one suggested we have two solutions. Let's try to draw it out. Okay, let's try to draw it out. Is it really true that we have two solutions? So I have a 3. I have a 3. This is my y1. Okay, so this is my y1. Then I have a 4 minus x minus 2. Okay, so I will have 4 minus x minus 2. Okay, did I do wrong calculation somewhere? Okay, so over here I have no solutions. 4, 1, 2, this one down. 4 minus x2, I have this answer. Okay, so although that over here they have suggested 2.5, okay, answer as 2.5 and 1.2, but when we put it back inside, Okay, when you put it back inside, checking. Okay, the left hand side, I have a 2.5 minus 3 modulus that actually give me 0.5. From the right hand side, I have a modulus of 4 minus 2.5, okay, minus 2 that actually give me negative 2.5. So the 2.5 answer is not true. Okay, 2.5 is wrong. Okay, if we do a second checking of a 1.5, okay, checking left hand side equals to modulus of 1.5 minus 3 equals to 1.5, but the right hand side over here, so you have 4 minus 1.5 minus 2, so you have a 2.5 minus 2, 1. This one 1.5, this one 2.5 minus 2, this is 0.5. So you will see that they are difference. So 1.5 is wrong. So in the end, there are no interceptions, no solutions. No solution for modulus of x minus 3 equals to 4 minus x minus 2. What does it mean entirely for these few examples? Number one, you cannot just use algebra once you get the answer and just leave it there. Number two, you need to consider all possibilities of forming the case. Number three, you can use graph to actually identify whether you have a consistent answers or not, provided you know how to draw the graph. Number four, checking your answers using using common sense to actually to figure out whether does it make sense or not. This is the thinking part, the analytic part that we want to train for further math students. Are you okay? Okay. Then after this, okay, is the inequality. Okay, after this is the inequality. Okay, so same thing first. Okay, we can tackle an inequality equations by solving equations. After that, we use test point to see whether is it work or not. For example, the first working. Okay, let's say modulus of x minus 3 equals to 4 minus x. Modulus of x minus 3 equals to 4 minus x. Okay, we managed to do x equals to 3.5. Then after that, I'm using 3.5 as my boundary. Okay, because we already solved it. So let's say the question is actually asking for modulus of x minus 3 is greater than 4 minus x. Okay, greater than 4 minus x. So what can we do? So we choose a number in between of 3.5. Okay, the number line separated into two parts, lesser than 3.5 and bigger than 3.5. Let's say I choose 0 and 10 over here. So 0 I substitute inside, I have a 3. This is a 4. 3 is not greater than 4. This one is out. Let's say I choose 10. I have a 7. 7, okay, this one is a negative 6. 7 greater than negative 6. This is true. So therefore, the answer is x greater than 3.5. Okay, we can always use test point method. Okay, or we can actually use graph. So this is my y1, this is my y2. Okay, this is 3 and 3. This is your modulus of x minus 3. Okay, and this is a 4 minus x over here. Okay, I need black greater than red. I need black greater than red. So you see that this is a point here, 3.5. The black greater than red. Black greater than red. So it's x greater than 3.5. Or we can actually use graph to solve the questions. Okay, understand? So far so good. Is it too difficult?
Yes, graph would be the always most likely the easiest approach for most of these questions, correct?
Provided students know how to do the graph lah.
Okay. Yeah.
Okay. So because there are graph involved, you are expected to remember graph and transformation. Transformations. Let's see what do you remember about the transformation. Okay, number one, we have fx of plus minus a. Number two, we have f of x plus minus a. Number three, you have a of fx. Number four, you have f of ax. Number five, you have negative of fx. Number six, you have f of negative x. Number seven, you have 1 over fx. Number 8, you have f inverse x. Number 9, we have a modulus of fx. Number 10, we have f of modulus x. Number 11, we have f of negative modulus x. Number 12, we have a sum of two graphs. Okay, number 13, we have product of two graphs. Can anyone tell me, still remember how to do this thing? What does it mean by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13?
Number one is translate up and down by A units depending on positive or negative.
2 is sideways.
Is number 3 compress and stretch the graph?
Which direction?
Up and down, correct?
Vertically.
Okay. Then number 4 is just sideways, compress and stretch
Of
of the graph. Compress and stretch of sideways, of like sideways.
horizontally. Number 5.
Reflection in the x-axis.
Number 6.
Reflection in y-axis.
Number 7.
Reciprocal.
Number 8.
Reflection to x equals y graph.
Number 9.
Folding in the x-axis.
Folding. Number 10.
Folding into y-axis.
Wrong.
Is this the one that you erase half the graph and then like you copy paste it the other side.
Give me the correct instructions.
Erase all the parts in the negative area and copy paste it to the positive. I think that's
Doesn't sound right. Okay, number 11.
Delete right hand side of the y-axis, copy and reflect left hand side to right hand side.
Okay. Sum of two graphs. You may have something like y equals to y1 plus y2. Okay, then you have to consider the graph. So product of two graphs, it could be y equals to y1 times y2. One of the common answer happened in P3 before is like x times ix. Okay, where the graph is actually like this. This happened in P3 patterns before. Okay, so the best part, I think the best is for you to practice the questions lah. Okay, so I let you try to do the questions. Please remember that right now you are entering the advanced level of maths already. Yeah? So therefore, try your best to actually adapt with the more complex type of questions. Which actually require you to actually to adapt with different techniques. Okay, there's no longer like easy type of questions. Just remember that. Okay, I'll let you try the questions first. Give it a try. I will turn off the recording now.